Hi everyone, today we are working on the present value of an annuity. So let's fill in a couple blanks here and get started. So the amount or present value, so PV stands for present value, of an annuity can be described as the amount of money that needs to be saved and invested in order to provide regular payments of a specific amount. It is also the amount of a loan or payment that will be paid for in regular payments. So here's the formula that we are going to be using to calculate our present value of an annuity. So PV equals R times 1 minus 1 plus I to the exponent negative n all over I. Okay, so we're going to look at an example. So R, remember, is regular payments. I is the interest rate as a percentage. And if there's a compound period, we have to remember to divide by the compound period. And n is the number of payments. So, and again, we might have to also multiply the n if there is a compounding period. Our first example, Kayla wants to retire at age 65. How much money does she need to have saved when she retires if she needs $20,000 per year to live and ends up living to be 90 years old? She can have the money invested at 3% compounded annually. Okay, so we're going to start by making our list of what we know. So we're going to decode the problem. So PV, R, I, and N. So the present value, that is what we're looking for. The regular payment that she wants every year is $20,000, a very modest payment. The interest rate is 0.03 compounded annually, so divided by 1 is just still 0.03, but I'll just put it in there for illustrative purposes. The N, so how long is between 90 and 65? Whoops, 65. So N is going to be 25 years. So 25 times 1 is still 25. Okay, next we're going to go ahead and plug that into our present value formula. So 20,000 times 1 minus 1 plus 0.03 to the exponent negative 25, all divided by 0.03. All right, if we go ahead and plug that in, we get $348,262.95. So she will need to save this much money. To retire. All right, let's look at another example. Brendan plans to retire at age 55. He wants to have $40,000 to live each year. If he lives to be 95, how much does he need to have saved in an account earning 4.5% compounded annually? Same idea as before. We're going to start by decoding the problem, figuring out what is the PV, what is the R, the I, and the N. So PV is what we're looking for. The regular payment that Brendan wants is, $40,000. The interest rate, so converting 4.5%, remember divide by 100, 0.045. And then compounded annually, so over 1. I don't really need to put the over 1, but for illustrative purposes, I will leave that. So the N is 95 minus 55, which is 40 years. So PV equals, so we're just going to go ahead and substitute everything into this formula. 1 subtract 1.045 to the exponent negative 40, all over 0.045. So the present value is equal to 736,063.38. So $736,063.38 is what he would need to save to retire. So make sure we put a therefore statement because it is a word problem. Shiori needs $2,000 per month to live when she retires at age 60. How much does she need to save? How much does she need to have saved in an account earning 2.4% compounded monthly if she lives to be 85? Okay, same idea. PV, RI, N. Let's decode the problem. We need to figure out the PV. The R is 2,000 per month. 0.024, this time compounded monthly, so divided by 12. And 85 minus 60 is 25 years. But because it's compounded monthly, we still have to multiply that by 12. And that's going to give us 300 payments. PV is equal to, so let's go ahead and substitute into our formula. 1 minus 1 plus 0 point, whoops, that plus looks like a T. Let me fix that. 0.024 over 12 to the exponent negative 300 all over 0.024 divided by 12. And go ahead and plug this into our calculator. Please be careful when you're plugging this into your calculator. Some calculators you can plug this in right away. I know on my calculator I have to open up a series of brackets. So for me on my calculator, I type in 2,000 and then I open up 3 brackets, bracket, bracket, bracket. 1, subtract, then I open up 2 more brackets, bracket, bracket. 1 plus, then I open up another bracket. 0.024 divided by 12. I close 2 brackets, exponent negative 300, close another bracket, hit equals, and then I hit divide, open up a bracket, 0.024 divide 12, close bracket, equals, and then we get 450,859.42. So therefore, they need to invest $450,859.42. So please include a therefore statement. It is a word problem. All right, let's look at number 4. Tegan is looking at buying a used car. The dealer tells her that her payment will be $450 per month for 3 years. Interest rate is 4.5% compounded monthly. What is the sticker price of the car? How much will Tegan actually pay for the car? So PV equals R equals 450, I equals 0.045 divided by monthly is 12, N is equal to, so 3 times 12, which is 36. Go ahead and plug that in. 1 minus 1 plus 0.045 divided by 12. The exponent negative 36, close my big bracket, all divided by 0.045 over 12. So PV is equal to, so again, 450, bracket, 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 1 minus, bracket, bracket, plus, 1 plus, bracket, 0.045, divide 12, close bracket, exponent, negative 36, close bracket, equals, divide, open up a bracket, 0.045, divide 12, close bracket, equals $15,127.61. So this is the sticker price. It says how much will she actually pay? So we have to take this one step further. So 450 times 36 payments, 16,200. We could take this one step further and I could say, well, how much interest did she pay? So 16,200 minus 15,127.61. I'm running out of space. Let's see if I can squeeze it in here. Equals $1,072.39 in interest. Anyway, that says interest. Hopefully you can see that down in the corner. Okay, we have one more example. Tal is buying his first house. His mortgage payment is $800 per month. For the next 40 years, the interest rate is 6.3% compounded monthly. What is the price of the house? How much will Tal actually pay for the house over the next 40 years? Again, decode the problem. Oops. So we're looking for the PV. 800 is the R. The interest rate, 0.063 compounded monthly, so divide by 12. 40 times 12, 480. Go ahead and substitute in. All right, plug it into your calculator. All right, so that's the price of the house. I'm running out of space. How much they actually pay. Multiply the payment, 800 times 480. And then we can subtract that to get our interest. I'm running out of space, so I'm going to cut this one a little bit short. They actually pay $384,000. And if you subtract that, the interest is $243,960.65. All right, that's it for this lesson.